Unit 5, Graphing and Solving Quadratics. A quadratic is any equation or a function that has an x squared term in it. And so we've spent a lot of time actually factoring quadratics, and you may not have known they were called that. Lesson 5.1 is specifically about parabola features. And so what happens when you have this x squared term, it creates this shape they called a parabola or a parabolic curve. And so it's a symmetrical open curve formed by a function with an x squared term. A parabola can either open up or down. So here is on my poster, it is the third one across the top row, y equals x squared. That's called the parent function. So every other quadratic is some kind of shift, reflection, rotation of this parent graph. Okay, and I want to show you why it makes this shape. So if I quickly made an XY table, which is how we can graph anything, if I have an x value of 0 and I plug it in here, 0 squared makes y equals 0. So there's a point here at the origin. If I plug in 1 for x, 1 squared gets 1. There's a point here at 1, 1. If I plug in -1 and square it, we know a negative squared is a positive 1. So at -1, it also goes up 1. Does that for 2 and -2. Plug those numbers in and square them, they both get a positive 4. It's kind of hard to see on here, but there and there. So that's why it has this symmetry. And then here's y equals -x squared. The negative makes it open down. Open down like a frown, and this opens up like a smile. All right, so the features you need to know, and we'll figure out how to find them later on, is the coordinates of the y-intercept. A y-intercept is where our graph or our function goes through the y-axis, and it wants it as an ordered pair. So for it to be a y-coordinate, the x value has to be 0, right? This point did not go right or left any, it just went up 5. Coordinates of the x-intercepts, which are also called the roots. So when you're finding the x-intercepts, it's also called the roots. It's where the graph goes through the x-axis. Sometimes there's 2, sometimes there's 1, and we'll even get to some later on in the unit that have none. Okay, so we've got at -1, it says coordinates. So x value is -1, the y value is 0, because it didn't go up or down, and 5, 0. Coordinates of the vertex. The vertex is the turning point. So on this, think of this as a roller coaster. This would be the turning point. You go from going up, you reach a max, and then you would drop. So this is the vertex, and it is at 2, 9. And then the equation of the axis of symmetry. You've learned that the Earth tilts on a certain axis. It's some kind of like imaginary line. And so what I want to do is draw an imaginary vertical line that cuts this parabola into 2 equal parts. And when you write an equation of a vertical line, you got to think about where does it cross through the x-axis at x equals 2. Okay, very important. You can't just say 2. 2 is not a number, it's not a line, it's nothing. You have to make an equation which is x equals 2. So if I were to graph it on my calculator, it would make this vertical line. And you should notice that the vertex has an x value that's the same as the axis of symmetry. That will happen every single time because the axis of symmetry cuts through the vertex. All right, number 2 should be pretty easy. So this one opened down. This would be a negative something x squared. This one opens up. This would be a positive something x squared. The y-intercept is here at 0, 4. X-intercepts are roots. See how there's only one time it touches the x-axis? That's still a root. That's a solution. So that would be -2, 0. Coordinates of the vertex, that is also the vertex. And then the axis of symmetry is the vertical line that cuts through that point. So again, it has to start with x equals -2. Okay, next page. The parabola a value. So you have to know that this is called standard form. F of x or y equals ax squared plus bx plus c. It's having your squared term, your linear term, which is something x, and then your constant number on the end. So what's going to happen here is, depending on what's in front of x squared, the a value, if it's negative, we said it opens down. If it's positive, it opens up. So use that for one thing. And then for 2, if the absolute value, meaning even if it's a negative, just ignore the negative. The number, if it's less than 1, so that would be a fraction like a half, a third, a fourth, it actually gets wider. If it's greater than 1, it gets skinnier. So what we're going to do is match these a values to their graphs. So first of all, I would see that this is a positive, positive, negative. This one has to go with the graph that opens down, which is this one. So I don't really care about it other than that. And then I'm down between these two, an a value of 1 and an a value of 4. Well, we just talked about if our a is bigger than 1, it gets skinnier. So that's this one, and that's this one. Usually they're not in the same order, but there they are. Okay, and you can see how this one is actually wider than the other two. All right, and then number 4, I see only this a is a positive one, so this has to go with the graph that opens up, would be that one. Then I'm down to these two. Again, ignore the negatives. We know that that makes the open down. 0.25 is a fourth. That's smaller than 1, so it's going to be wider. So that one goes with this one, and then this one goes with this one. All right, and the last thing we're going to do is find the axis of symmetry in the vertex by hand without having the graph. And so there's this formula you'd have to memorize, that to find the axis of symmetry, it's x equals negative b divided by 2a. Our a value in this problem is the number in front of x squared, so that's negative 1. Our b value is the number in front of x, that's 10, and our c is negative 33. So we'll go x equals a negative of our b over 2 times our a, which is negative 1. A negative of 10 is negative 10. 2 times negative 1 is negative 2. Negative 10 divided by negative 2 is positive 5. And so it's going to want the equation, so it's x equals 5. That's that vertical line that cuts the parabola into equal parts. And number 6, our a value is 3. We don't have an x term, so our b is 0, and our c is negative 9. So we'll take x equals a negative of our b over 2 times our a. A negative of 0 is not possible. It's just 0 over 6. 0 divided by anything is 0. So at x equals 0, that's our axis of symmetry. So our parabola must be doing this somehow. And then the last thing is taking it one step further and finding the coordinates of the vertex. Remember how we talked about every parabola, wherever its vertex is, it also has that same axis of symmetry that goes through that x value. So if we could find the x of the axis of symmetry, then we'll be able to get the y to get the coordinate of the vertex. And so in this problem, my a is a 1, my b is negative 10, my c is 34. X equals a negative of my b, which is also negative, over 2 times a. So a negative of negative, negative times negative is positive 10 over 2, which is 5. So I now know that my vertex has to be 5 comma something. And then when you want an ordered pair, this equation helps you find it. We know that x is 5. So I'll plug it in every time I see x. 5 squared is 25. Negative 10 times 5 is minus 50 plus 34. 25 minus 50 is negative 25 plus 34. Would be 9. So my vertex is at 5 comma 9. And then number 8, my a is negative 1, my b doesn't exist, it's 0, my c is negative 1. So to find the axis of symmetry, x equals a negative of b over 2 times a. Doesn't really matter what down here is because it's still 0, so that is the x value of my vertex. And then I would just plug it in. So my negative's coming first. It's a negative times whatever my x value squared is minus 1. Exponents come first. 0 squared is 0. No such thing as a negative 0. But if this would have been a number, make sure you're squaring first, then times by a negative 1. And 0 minus 1 is negative 1. That's what y is when x was 0. When x is 0, you could also just think, okay, any terms with an x really are just going to be 0, and whatever the constant is on the end, that's my y value.